also how to back up virtual machines. On that note, let's go to the next topic, which is Azure Backup Center. Azure Backup Center. Azure Backup Center provides a unified management experience for enterprises to oversee their backup estate across hybrid and cloud environments. Azure Backup Center is designed as a single pane of glass management solution, simplifying the oversight of backup operations across a large and distributed Azure and non-Azure environment. This means administrators have a consolidated view and control over all their backup assets regardless of their geographical distribution. The service focuses on data source-centric management, which allows for a more granular and informed approach while dealing with various data sources. Whether it's virtual machine, databases, or file shares, Backup Center gives you specific tools and policies tailored to the nature of the data you're protecting. Azure Backup Center offers connected experience through native integrations with other Azure services, enabling seamless management at scale. These integrations facilitate complex tasks such as automated backup scheduling, policy application, and compliance reporting, making it easier to manage backups for large-scale operations. By providing these features, Azure Backup Center aims to simplify, optimize, and enhance the backup and recovery process within the Azure environment. Backup Center is free to use. You can simply go to Azure portal and search for Backup Center. If I do that right now, there'll be nothing inside that because I'm not backing up anything. Once we have some demos for files and folder backup and VM backup, we will revisit Azure Backup Center so that we have some data to view. On that note, let's start with file and folder backup. File and folder backup. So in this lesson, we will see how we can back up files and folders from on-premises as well as from Azure file shares. First of all, we need to create a service in Azure. It's called the Recovery Service Vault. This is where all our data is going to get stored. Under the hood, it's a storage, but as I mentioned in the benefits of Azure Backup, it's a managed storage and we call it as a vault. Setting up backup for Azure files is very easy because it's an Azure native service and you can simply configure with a couple of clicks. But for on-premises, probably you'll be saving your files inside a Windows server. There you have to install something called MARS agent, Microsoft Azure Recovery Services agent. This agent is responsible for replicating your files to the Recovery Service Vault. So let's see how this can be implemented. From Azure portal, I also have a VM that is deployed on-premises on Hyper-V. We will see how we can set up the MARS agent as well. Starting with Azure portal. So in Azure portal, I'll go to storage accounts and I'll create a file share there. I'll start creating a storage account here. Let me choose the subscription and create a new resource group here. Let me call this as hope that's not taken. And this will be standard. I'll be using LRS, advanced. I don't need to review anything, so I'll just go ahead and create the storage account. Once the validation is done, we will create the storage account. After that, we will configure a file share, upload some files to it. Then we will deploy the Recovery Service Vault. After that, we will try to delete some files from there and see how we can recover that. So our file share or the storage account is deployed. I'll go to the storage account and I'll go to file shares. I'll add a new file share here. Let me call this one as RSV demo. Here itself, I can configure the backup by just enabling the backup, but I want to show you the way how we can create a recovery service vault. So I'll not create it from here right now, but I'm going to enable it later and create the file share. So the file share is created, but the backup is not enabled as of now. I'll go to browse. I can upload files here. So I'm going to upload all these images here. Click on open. And it's checking for named conflicts. Once that's done, it will upload the files to the file share. I'll click on upload because there are no named conflicts. So our files are getting uploaded to Azure File Share. Now we'll see how we can configure the backup. I could do it from here itself, but let's just go to Recovery Service Vault. I'll create a new Recovery Service Vault here. We'll place in RG Data Protection, RSV01, East US. I don't want to go for a private endpoint or anything. I'll just click on Review and Create the Recovery Service Vault. So the Recovery Service Vault will be used throughout this lesson for files and folders backup, for virtual machine backup. Your Azure Site Recovery is also set up inside the Recovery Service Vault. So it's a service that's going to come up every time in this module. So our Recovery Service Vault is deployed. I'll click on Go to Resource. Here I'll go to Backup. Now the question is, where is your workload running? As of now, our workload is running in Azure. And what do you want to backup? I want to backup file share. I'll click on Backup. Now it will ask me to select the storage account. So our file share is visible here, or the storage account is visible here. I'm going to select that. I can also enable a lock on the storage account so that I won't delete it accidentally, but I will not enable that because I have a script which will clean up my subscription every day. So it's going to register the storage account with the Recovery Service Vault. It's going to take some time for registering the provider. Once that's done, you can add the file share here. Then we can specify the backup policy, like what is the backup frequency, how long you want to keep the backup, which is a retention policy as well. After that, you can enable the backup. So the registration is completed. I'll click on Add, and our file share will be visible here. I'll click on OK. I can edit this policy and change as required. For example, what is the backup schedule? Weekly backup point, monthly backup point, yearly backup point. I can configure all of this. By default, it has a retention up to 30 days. If I want to increase the retention, I can do that as well. I'll go with the default option. I'll save it, and I'll click on Enable Backup. So our backup is enabled. I'll click on Go to Resource. It will take me to the Recovery Service Vault. If I go to Backup Items, I'll be able to see the file share here. I'll click on that. So I'll open this one here. It says the warning, initial backup pending. So I'll go to the view details. I'll back up right now so that we have the initial backup. And I can put the retention date as well. So it's triggering a backup for our file share. Once that's done, what I'll do is I'll go to the file share, I'll remove some files and see if we can recover from our Recovery Service Vault. So let's wait for the backup to get finished. So our initial backup is finished. I'll just refresh this. And it says success. Perfect. So I'll just duplicate this tab here. And I'll go back to my storage account. Inside file shares, I'll go to my file share, browse. I'll delete this one here and this one as well. So our city 1 and 2 is deleted. Now I'll go to the details of this backup item. I have the option to restore the entire share, or I can go for a file recovery. So I'll go to file recovery. I'll select the restore point that I did manually. Once you have automatic backup coming in, you will have multiple restore points. So you have the option to restore to the original location, or you can go for an alternate location. In case of conflicts, what you need to do. So I can skip it or overwrite. Now what I'll do is I'll click on Add File. I'll be able to choose city 1 and 2, select, and restore. So it's triggering a restore process for our file share from the Recovery Service Vault. Once this restore process is completed, we will have our city 1 and 2 available here. As you can see, city 1 and 2 is back. So this is how you can use backup for file share. In case you want to restore the entire share, you can go with this option. Now we will see how we can backup files and folders that are on premises. This applies to files and folders that are outside Azure. So I'll go to backup again. This time, instead of Azure, I'll choose on premises. I'll select files and folders, and I'll click on Prepare Infrastructure. This requires the installation of a Recovery Service Agent, also known as MARS. So I have a Hyper-V machine running here with some files inside the documents. I'll close this one. And what I'll do is I'll download this agent. Once it is downloaded, what I'll do is I'll copy this file to my Hyper-V machine. So let me copy it to downloads. I can install this package on my Windows server. I also need to download the credentials for my vault because I have to link it to my vault. So this will be a file that is downloaded. Locally, it's called Vault Credentials. Basically, it's a text file. I'll just open that with Notepad in the screen and bring it here. So this is how my Vault Credentials file look like. It has all the information that is required to connect to the vault. Going back to my Hyper-V machine, before I install, I'll pull in the Recovery Service Vault credentials also. This is only valid for 10 days. So our credentials are here. Now I can go to the installation. This is going to get installed in this folder. This is the cache location. I'm not using any proxy. This goes to the internet, but if you want it to go to the private network, you can create a private endpoint for your Recovery Service Vault. I don't want to do auto update, but if you want to check for updates through the Windows Update, you can enable this option. Next is installation. I'll click on install. So the installation is completed. I'll click on proceed to registration. This is where I need the credentials to the vault. So it's asking me for the credentials. I'll click on browse. I'll choose a credentials file. So it automatically picked up the subscription, the region, the vault name. Click on next. So I can protect the backup using a password. So it should be at least 16 characters of length. Let me generate one from here. I don't want to integrate to Key Vault, so I'll just escape from that option. I will save it somewhere in my PC locally. So let's say desktop. It's not the secure location, but I'll just keep it there. So our server is successfully registered. I'll click on close. And if I go to all programs here, I'll have the Azure backup available here. This is how it looks like. So here, what I need to do is I need to schedule backup. So I'll start from here, add the items or select files and folders that you want to backup. So I'll expand C, users, administrator, documents. That's where my images are. I can create an exclusion as well if I want to exclude something, but I need everything inside that folder. Now you specify the backup schedule. You can have up to 3 times a day. This is set to 7:30. That's fine with me. I can choose the retention period. I'll go with the default option. Now the initial backup. There is an online option. That means it will transfer over the network. It will use my network to send this information to Azure. I have options like using Databox, or I can transfer using my own disk to Azure. This is quite useful if I have a large amount of data, then I can go for the offline backup. In our case, it's a bunch of images. I can go with online. Confirmation, finish. Now it's creating the backup schedule and it will start the initial backup now. So I have the option to click on backup now. This will back up the folders that I have added to the list. Due to an issue with the Hyper-V switch, my backup failed once, but I managed to restart it and it says the backup is done. What I will do right now is I'll go to my documents folder and I go to documents. I'll just delete these files. So it's gone. Also in Azure portal, let's see if we have any reference of the backup. So I'll go to the Recovery Service Vault, backup items. So you have Azure backup agent showing here. If I open that one, it says access. I can view the item. So it says files and folders. This is a computer name. Last refreshed at this time. I only have 1 recovery point so far. Now, how do I do the restore? So we have to go back to the server to do that. Here I have an option to recover data. So if I click on that, you can use this wizard to recover files. To get started, identify the server on which the backup was originally created. This is the server. Select the recovery location. I'll just go with the primary region. The recovery mode, individual files and folders, volume, the system state, files and folders. Select the volume and date, it's C/. It will fetch the recovery point for me, which was taken at this time. I'll mount it. Now this will mount a drive on my computer with the backup. So from there, whatever files I need, I'll be able to copy it and bring it back to my documents. So the mounting is done. This will be available for almost 6 hours. If needed, I can extend. Let's say I have a lot of files that I need to recover, then I can extend it up to 7 days. So I can click on browse and this will launch a folder here in my this space, users, administrator, documents. I have my CD pictures here. I'll just drag and drop them to documents. I'm done with the recovery. So what I can do is I can go back here, unmount. My recovery is finished. So I have my files back here in my documents. There you go. So that's how we work with files and folders backup in Azure and on-premises. In the next lesson, we will talk about virtual machine backup. Virtual machine backup. Let's start with the backup of virtual machines in Azure. So I have a VM in Azure with managed disk attached to it, and I want to take backup of this machine. So first of all, there is a backup service which is responsible for managing the backup. When you set up a backup for an Azure VM, Azure Backup Service automatically installs the backup extension to the VM if it is not present. This extension is responsible for orchestrating the backup operations within the VM, ensuring that the data is consistent. Now, during the configuration, what happens is there will be policies involved, retention period. All this will be managed by the policy management system. So when you create the configuration, you will specify, let's say I want to take backup every day at 7 a.m. I want to keep this backup for another 30 days. I have my weekly retention period, monthly retention period. So you'll configure everything and you'll create a backup policy. So when the time comes, what happens is, let's say your backup is at 7 a.m. and now the time is 7 a.m. The backup service will send a request to the extension to initiate the backup. So during this process, what happens is the backup extension initiates the creation of a snapshot of the disk attached to the VM. This snapshot captures the state of the VM at a specific point in time, including all data on its managed disk. If an application consistent backup is required, the backup extension coordinates with the Volume Shadow Copy service, which is a VSS service on Windows VMs, or use the post scripts on Linux VMs to ensure that any in-flight transactions or caches are flushed to the disk before the snapshot is taken. This ensures that the applications are in a consistent state when the backup is taken. Now that you have the backup, the next process is to send this data. That's where the recovery vault comes into the picture. The backup data will be sent as incremental blocks. So Azure Backup uses incremental backup to capture only the changes since the last backup. This is more efficient as it reduces the amount of data that is transferred and stored, and it also speeds up the backup process. The data from the snapshot is securely transferred to Azure Backup Service over HTTPS. The transfer is encrypted, ensuring that the data is secure in transit. If your VM is an encrypted virtual machine using Azure Disk Encryption, what happens is during the backup process, the key is also exported to the backup, so that whenever there's a restore process, we can use the right decryption key set. All right, let's see how we can create backup for virtual machines. So I'll go to virtual machines here, and I have a VM which is called RSV Demo 1. So I'm going to enable backup for this machine. This machine has a web server running inside this one. So if I call the public IP, I'll be able to access the web page. But we will not need the web server at this point. I'm just preparing the infrastructure for the upcoming lessons as well. So if you want to do backup, the first thing that you need is a recovery service vault. So if you remember the architecture, end of the day, our backup is going to get stored in recovery service vault. So I need to go to recovery service vault here. I already have one which I created earlier for the files and folders demonstration. I'll open this one, and I have option to add backup from here or go here. Now I could directly do it from the virtual machine itself. That's good if you have one machine or two machines, but if you have, let's say 10 or 15 machines, it's better to come here so that you can do a multiple check and onboard them all together. All right, so our workload is in Azure. I want to back up a virtual machine. I'll click on backup. So I have two options available. Once a day backup, 1 to 5 days operational tier, vault tier. With the ZRS, Trusted Azure VM is also supported. Then there is enhanced mode. I'll go with standard. Now this is our default policy. I can have a new policy here. Let me call this as a VM backup policy. I'll just remove typo. So the daily frequency at what time you want to take the backup, let's say 4 a.m. in the morning. You see if you want to change it to your time zone, you'll be able to choose that. Instant restore, so there will be instant recovery points. Remember the snapshots that we discussed. So how long those should be kept. So the default is 2 days. If you want to change that, you can change that as well. So every day 4 a.m. that will be retained for 30 days. Weekly, you can take one backup and you can configure on what day that weekly backup should be taken and how long that should be kept. Similarly, monthly backup, on which day of the month you will take a monthly backup and you'll keep it for how long. And finally, yearly backup. So which day of the year, in which month you want to take the backup and how long you want to keep it. So in this way, you have different restore points from different timelines and you'll be able to keep it. Right. So once you click on OK, the backup policy will be shown here. And this is where you can add the virtual machines. I'll click on add. Now I'll be able to support all the virtual machines available in this region. So it takes a second sometimes to show up all the machines. Yeah, after a refresh, I'm able to see our virtual machine here. I can click on this. If I have multiple machines, I can check all of them one by one. I'll click on OK. So during this process, what happens is it's doing invalidation to check if we can install the backup agent there or the extension there. And once I click on enable backup, the extension will be installed on our virtual machine, which is responsible for orchestrating the backup. So the deployment is for installing that extension. So if you look at the operation details here, we can see that it's getting added to the backup item. There is a extension resource that is going to get created, and that will be mapped to our virtual machine. So let's wait for this installation to complete. After that, we need to initiate our first backup like we did for Azure files. So our backup is configured, and I'll click on Go to Resource. That will take me to the Recovery Service Vault. If I go to Backup Items, I have my virtual machine here. This is something that we tested for the previous demo. And if I click on Virtual Machine here, we can see our RSV1 is here. And if I click on View Details, I'll be able to take the first backup. So let me do that. This is the first backup that we are creating. So once the backup is created, we will be able to see the restore point here. So let's wait for the backup to finish. Clicking on this jobs will give you a better idea about what's happening. So the backup, this is for the file share that we did earlier. Backup configuration was complete. Now the backup is initiated. I can click on View Details to see what's happening. So it's taking a snapshot right now. Once the snapshot is taken, it will transfer that data to the Recovery Service Vault. So we will wait for that one. So the snapshot process is finished. Now we just need to transfer the data from the machine to the vault, which will be taken care of by the extension. So if I refresh this, soon this process will start. And once that's done, we'll have our backup in Recovery Service Vault. So our backup is finished. You can see it was successful, but the date is incorrect. Nevertheless, I can see the oldest restore point, which is like 10 minutes ago. That's a good thing. So this is how we do the backup for our virtual machine. I can do a restore of the VM, or I can do a file recovery as well. So if I click on file recovery, I have to select a restore point. Then I need to download the executable. Once that's done, it will do the same process as we have seen in the case of Mars. It will mount a disk. From that disk, we can recover whatever files that we want. Now, when it comes to restoring the VM, we have to select the restore point for that. This one, I'll select it. Now, when you restore, there are two options. You can create a new virtual machine, or you can restore the disk. So if you're testing something went wrong, you want to check, it's better that you create a new virtual machine and see if restoring will help. If it really helps, then think about restoring disk. But for some reason, if you know that, okay, this is something wrong with the disk itself, something corrupted, you can go for restore disk. So I can choose restore disk. I have to choose a resource group and the location where exactly I want to create that staging account. It's not going to directly replace my disk. I have to create a location inside my storage account where to restore this. Once that's done, this will be available in my storage account as a VHD file. I can then use it to recover the data that I need. So these are the two options that I have. I have another option here, which is called replace existing. So if I already have a backup of a disk, I want to replace the disk, I can go for this option. But if you're creating a new one, like the first time restore, then you can go for the create new option. So once the restore process is initiated, it will take some time to finish, but it's a job that will be started, and we have to monitor the job to understand the progress of that. Once that's done, you can get the new VM, or you can use the disk that is created, create a snapshot out of it, and then mount it and see how it goes. With that, we have completed the backup of Azure virtual machines. Now we will see how we can backup and restore on-premise virtual machine. Virtual machine backup on premises. So when it comes to the backup of on-premise VMs, we can use Recovery Service Vault for storing the backup. Now, the Recovery Service Vault supports specialized workloads like Exchange, SharePoint, SQL Server. You can also have VMs that are running on Hyper-V and VMware, be it Linux or Windows VMs. We can take a backup of that. In addition to that, Windows Server physical servers are also accepted by Recovery Service Vault. If this was in Azure, things would have been much easier because you can just configure it from the portal. Now here, what we are using MABS or DPM, Microsoft Azure Backup Server or System Center Data Protection Manager. This is used as a bridge between the on-premise environment and Azure. These tools orchestrate the backup process, including the scheduling, retention policies, and transfer of data to Azure. The data is transferred securely over the network using an encrypted connection, typically HTTPS, to ensure that it cannot be intercepted or compromised. So the backup will be stored in Recovery Service Vault. However, there will be a local backup as well. In case something goes wrong, you can easily restore it from on-premises. So there will be two copies, one in on-premises, which can be easily accessed from on-premises because of the low latency. Another copy will be in the cloud, which can be used in case something goes wrong. So I'm in my Recovery Service Vault right now. I'll click on Backup here. Now my workload is running on-premises, and I want to back up a Hyper-V virtual machine. I'll click on Prepare Infrastructure. Now it says I will have to download the MABS or the backup server. So the process is somewhat similar to what we have seen in the case of MARS. You have to download the package, then you have to download the Vault credentials and configure the backup from the UI that is on premises. Now, if you're using SCM or the System Center Configuration Manager, you can check this box and it will give you the options using the DPM agent. Due to the lack of resources in on-premises, I will not be able to demonstrate this, but from Azure standpoint, this is what you have to do. Rest of the configuration is done on-premises. Once you enable backup from your MABS, the data will be coming to the recovery service vault. So that's all we have in this lesson. Now let's take a comparison between MABS and MARS. Compare on-premise backup options. So we have our comparison here, MARS versus MABS. So the benefits. MARS agent allows backup of files and folders on physical or virtual Windows operating system without the need for a separate backup server. This is something that we have seen in the previous lesson where we installed the MARS agent and synchronized the backup, and we try to delete the backup and then restore it from the machine itself. When it comes to backup server, it provides application-aware snapshots, flexible backup scheduling, granular recovery options, support for Linux on Hyper-V and VMware, and doesn't require a System Center license. Now the limitations. MARS agent is limited to 3 backups per day. If you recall the UI of the MARS agent, you can put 3 time slots. And it is not application-aware. It can only restore files, folders, volumes, and there is no support for Linux. When it comes to the backup server, you cannot backup Oracle workloads. It requires an active Azure subscription and doesn't support tape backup. Now, protects. MARS agent is supposed to protect files and folders, while the backup server can protect files, folders, volumes, VMs, applications, and workloads. Now the storage. MARS agent stores the data completely in a recovery service vault, and the backup server uses the recovery service vault for storing the backed up data, and you also have a local copy of the data. This is what I mentioned earlier. So in case you want to quickly restore something, the data is available with low latency. With that, we have completed the backup of virtual machines in Azure and on-premises. Now we will take a look at some of the Vault data protection methods like soft delete. Vault data protection. Azure Backup's soft delete feature is a feature that is designed for data protection, which comes into play even after a delete command is issued. Let's walk through the journey of a backup item with soft delete enabled. Initially, the data is safe, backed up, but a time may come when you decide to stop the backup. This is where soft delete shines. Instead of the data vanishing forever, it enters a soft deleted state. Think of it as a pause, giving you a window to reflect or react if the deletion was unintended or erroneous. During this critical period, if you choose to stop backup with retained data, the backup item doesn't continue to create new backups. Yet your existing data remains untouched, protected, and restorable. It's a standby mode that retains your data without accumulating further backups. So you have 14 days available where you can make the decision. Now, if the deletion is final, the purge step is your endpoint. It's a deliberate action that wipes the data permanently, leaving no traces behind. It's an assertive measure for when you are certain that the data must go. But what if there is a change of plan? What if the data deletion was a mistake, or you realize that the data is indeed necessary? This is where the resume stage steps in. By receiving the backup, you lift the data out of its soft deleted limbo. The backup item springs back to action, picking up from where it left off, ready to continue its role in your backup strategy. So when soft delete is enabled, any deleted data is retained for additional 14 days. Also, you can increase the number of days and extend it beyond 14 days, although it has a fee associated to it. During this grace period, if you realize that the backup was deleted by mistake, you can easily recover it using the undelete operation. The feature is not just limited to virtual machines, it is also applicable to other backup items that is protected under the recovery service vault. Moreover, this functionality is natively built into all recovery service vault, ensuring that your backups have an extra layer of protection by default. So let's go to Azure Portal and see how we can use this feature or configure this one. So I'm in Azure Portal and we need to go to the properties of the recovery service vault. In the properties, you will be able to see security settings. This is where you can configure the soft delete settings, like the soft delete for cloud workloads, for hybrid workloads, the retention period, you can configure all that. So make sure that you leverage this feature to avoid unintended deletion of your backup data. Perfect. So far we covered backup in Azure. Now let's think about disaster recovery in Azure. Azure Site Recovery. Azure Site Recovery, or ASR, provides business continuity by ensuring that your virtual machine workloads continue to run from a secondary location if a disaster happens. In this scenario, we have a source environment in region A consisting of virtual machines that are running within an availability set. These machines are configured with a VNet and everything so that they can operate from this region A. Now what I will do is I'll enroll these machines to Azure Site Recovery. During the process, an extension will be installed on these machines and a cache storage account will be created in region A, which is an interim storage area for data replication. During the process, a similar setup will be created in the target region as well, which is a region B. You'll have a subnet, availability set, VNet, everything will be created in that region as well. So what happens is, with the help of the cache storage account, the data will be replicated to disks that are sitting in region B. Now, in case of a primary site failure, what happens is, virtual machine instances will be created in the secondary region, and these will be attached to the disk that is replicated from region A. So our machine will have all the data that was replicated from region A, and it will continue to work from region B. So this is how we implement business continuity in Azure using Azure Site Recovery. This is not an automated process, but you could automate this with the help of REST APIs, health metrics, and load balancing solutions like Azure Traffic Manager. So let's go to Azure portal and see how we can create this for a single VM. So I have my virtual machine here, which is RSV Demo 1. What I'll do is I'll just copy this to the clipboard, paste it, and we can see the IIS server running from the Windows machine. Now what I want to do is I want to configure disaster recovery for this machine. So I'll click on this option here. Now I could create a recovery service vault and do it from there as well, but I just wanted to show you this map and how it looks. So we can choose the target region here. I'm going to choose West US because this machine is in East US. In advanced settings, you will have all the infrastructure created there, including the resource group, the virtual network, the availability. You can configure all that. So everything will have ASR at the end. For example, the resource group name is RG Backup RSV, but it's going to be RG Backup RSV ASR Invest US. Ours is a single instance, so I'll choose that. Proximity is not applicable because it's a single instance. The capacity reservation is not required. This is for reserving the capacity. Storage settings, this is where you set up the cache storage account. Replication settings, this is where you configure where you want to keep your recovery service vault, the vault resource group, the replication policy. And extension settings, how you want to manage the ASR extension that is deployed to the virtual machine. So once you're done, you can click on review and start replication, and you'll be able to see all the items that are going to get created. So this is our source disk. This is our replica disk. It's going to be premium SSD. This is the cache storage account. I'll click on start replication and it will start creating the target resources in West US. Once that's done, it will start replicating. Then we will try to do a failover to West US and see if our VM is working from there. So this process is going to take some time. So I'll just pause the recording and come back once the replication is done. So our replication is completed and you can see the RPO here is 4 minutes. It's healthy and it's protected. We can also see the infrastructure view. This is my virtual machine in East US. Have the cache storage account. It goes here through site recovery, and a managed disk is created in our disaster recovery region. Now what I need to do is, you can see that last successful test failover never performed. So if you want to do a DR drill, you can do the test failover. So let me do that right now. So my source is East US, destination is West US. I can choose different recovery points, the lowest RPO, lowest RTO, the app consistent. So I'll go with the latest one. And the virtual network is the ASR virtual network, which we created as part of the onboarding. Now I'll do a test failover. What the system does right now is it's going to create a virtual machine here and attach this managed disk to that virtual machine. Meanwhile, what I'll do is I'll go to public IP address because we need to keep a public IP address in our DR, which will be used by our virtual machine. This will not be created automatically. So what I'll do is I'll create a new public IP here and I'll keep it on standby. Once a VM is up, I'll attach it to the VM. So I'll keep it in our ASR resource group. Let me call this as the RSV DR VM IP. And I'll create this one. So we have our test failover running in the background. I'll create this public IP right now. So our public IP is created. We just need to wait for this test failover to finish. So it's preparing the virtual machine right now. Once that's done, it's going to start the virtual machine. So our virtual machine is started. I can just click on this one. And we can see that the virtual machine is started. So let's go to virtual machines and see if we are able to find, yes, here is the one with the test name on it. So what I'll do is I'll simply go to the networking to check if the NSG is all right. So here we don't have any NSG as of now. So we need to create a network security group as well. Ideally, these things will be on the standby, but in our environment, we haven't created anything. So I'll create NSG here. This will be in our ASR resource group. dr nsg vestus review and create the nsg. So nsg is created. I'll go to resource here and I'll add inbound security rules. Add rule. So here I'll make it as port 80 M3389 TCP allow. Let me call it with the name default underscore rules. I'll add this rule here. Then what I'll do is I'll go to subnets. I'll associate the DR subnet here so that any VM that is created there will have this one. So the VNet is automatically selected and the default subnet, I'll click on OK and the association is made. Perfect. Now the only thing remaining is the public IP address. My DR VM IP is here. I'll have the option to associate. Resource type is network interface and I'll pick the test VM here. Click on OK. The interface is saved successfully. Now what I'll do is I'll go back to virtual machine, or I can directly copy this IP address and paste it here and hit run. And we are able to see our IIS page. This was exactly what we had in our production region. Now the test failover also shows the same page. This means that the VM is replicated successfully. So once you're done with the DR drill, what you can do is you can delete the resources. So you can come back here, go to the replicated items. So you have this option here, cleanup test failover pending. So which will be here, cleanup test failover. Testing is complete, delete the failover virtual machine. Now my test machine will be deleted. Now if I want to do a full failover, like the production one, I'll have this option available after our first test failover is finished. So I can do a failover from here and that will failover my workload to the DR region. So this is how you work with site recovery. There are other extended options available like the recovery plan, automation, traffic manager, but for the exam, it is not required. You just need to know that how the failover is done. Once the primary region is back online, there is a reverse process that you have to do, which is called resynchronizing, and then you have to commit it to switch back to the primary region. So we don't want to get into those details. And that's all we have for site recovery. Administer monitoring. In this module, we will cover three key objectives to enhance the observability and operational excellence of Azure services, starting with configuring Azure Monitor. This involves setting up Azure Monitor to collect, analyze, and act on telemetry data from Azure and on-premise environments. It helps to understand the performance and health of applications, infrastructure, and network. Configure Azure Alerts. This objective focuses on creating alerts based on metrics and log data from Azure Monitor. Alerts notify you of critical conditions and potentially take automated actions based on triggers. Configure Log Analytics. This involves setting up of Log Analytics workspaces for querying and analyzing log data collected by Azure Monitor. It allows the creation of complex queries to delve into the data, visualize it, and derive insights for decision-making and troubleshooting. So let's start with Azure Monitor. Azure Monitor. Azure Monitor is a comprehensive solution within Microsoft Azure that provides full-stack monitoring, advanced analytics, and intelligent automation across applications and infrastructure. It allows you to collect, analyze, and act on telemetry data from your Azure and on-premise environments, also non-Azure cloud providers. This will help you to understand how your applications are performing and proactively identify issues affecting them. Now let's take a look at the architecture of Azure Monitor, starting with data sources. This is where monitoring begins. With Azure Monitor collecting data from various data sources such as applications and workloads running on Azure, other clouds, or on-premises, infrastructure components including virtual machines and network, the Azure platform itself, then custom sources that you may set up to collect specific data. All this data will be coming to Azure Monitor service. And as a first stage, we have the data collection, routing, and transform. This is where the data is transformed with the help of agents, data collection rules, your diagnostic settings, etc. At the heart of the architecture is Data Platform, which acts as a central repository for all telemetry data. It processes and stores metrics, which are numerical values that describe some aspect of a system at a particular point in time. Logs, which contain timestamp information about operations and changes. Traces, providing detailed information about application code execution. Changes, recording modifications in your Azure resources. The collected data can be consumed in various ways for insights, visualization, analysis, and response. Insights are provided for applications, containers, VMs, and network resources, giving a deep understanding of their performance and health. Visualization tools such as workbooks and dashboards are used to create interactive visual representations of the monitoring data. Power BI and Grafana can be also used to integrate for advanced visualizations. Analysis is conducted using tools like Metrics Explorer and Log Analytics, which allow for in-depth examination of the data. Change analysis helps you to understand what changes occurred in the environment. Response mechanisms include AI-powered features like AI Ops and automated actions like alerts and autoscale, which help mitigate issues proactively. Organizations that are using System Center Operations Manager or SCOM, Azure Monitor can integrate with it. This allows data from SCOM-managed instances, including databases, to be included in Azure Monitor for a unified monitoring approach. Integration. Azure Monitor integrates with various services for expanded capabilities. Event hubs and Azure Storage for event and data ingestion. Managed partners for third-party service integration. Import-export APIs, logic apps, and functions for processing data and automation. Finally, Azure DevOps and GitHub for DevOps processes. So this is the full suite of Azure Monitor, but we will focus more on the metrics and logs because that's what's important for the exam. So let's start with metrics. In Azure Monitor, metrics are numerical values that are collected at regular intervals, like this, and describe some aspect of a system at a particular time. Metrics are used to provide near real-time view of the health and performance of different resources. For example, the CPU usage and the network traffic are common metrics that are monitored in virtual machine to ensure the system is running optimally. So there is no additional configuration required to collect the metrics. They are available out of the box. Time series. These are plotted in a time series to represent the state of a system. The metrics are updated frequently, providing a timely and accurate picture of system performance. That's why it's called near real-time data. We also have logs in Azure Monitor, which is another data store. Logs in Azure are critical for diagnosing issues, understanding system behavior, and performing complex analysis of data collected from different sources. They are structured records that capture events or changes in your environment. Unlike metrics, which are numeric and provide performance information, logs can include a wide range of data types and are often more descriptive. Each log entry is a record that contains different fields of data. These fields can include a timestamp, resource identifiers, event details, and more. The structured nature of these records makes it easy to search and filter the logs to find specific events or patterns. While Azure provides default logging for many services, detailed logging often requires additional setup. This could involve enabling diagnostic settings on a resource, configuring agents for virtual machines, log collection, machines, etc. Azure uses Kusto Query Language or KQL for log queries, which is a powerful language designed to make your data easy to retrieve, consolidate, and analyze large amount of data. KQL can handle complex queries, including joins, aggregations, and advanced analytic functions. Logs are a fundamental aspect of monitoring and troubleshooting in Azure, providing the detailed, granular data necessary for in-depth understanding of your applications and infrastructure. Though Azure Monitor supports a variety of data sources, let's take a look at the ones which are relevant for the exam. In Azure Monitor, various data sources provide a wealth of information for monitoring the health and performance of your applications and infrastructure. First one we're going to take a look at is application. This data source captures telemetry from your applications, allowing you to monitor the performance and usage. It includes data collected via instrumentation packages like Application Insights, which is integrated into your application code, and availability tests that monitor the availability, performance, and functionality of your web applications. Operating system. Operating system level data is captured by Azure Monitor Agent and diagnostics extensions, providing insights into the performance metrics and operational events of the virtual machines. These are the resources running in Azure, such as virtual machine, databases, and storage accounts. As we mentioned earlier, with the help of metrics, we can get some performance indicators, while resource logs offer detailed diagnostics and auditing information. Subscription. Subscription level monitoring includes service health monitoring, which provides information on Azure service issues, and activity logs that record subscription level events, such as resource creation and modification. We do have a dedicated lesson on activity log. Azure Tenant. This encompasses organization-wide data sources such as Active Directory, Entra ID, logs, which provide information on user activities and security-related events across your Azure tenant. Custom. You can also create custom data sources to monitor the data and telemetry that isn't captured by default. This might include custom applications or specific instrumentation for specialized workloads. All this data will be ingested to metrics or logs, which can be further queried using different tools that are available in Azure. Now, let's learn about Azure Activity Logs. Azure Activity Log. Azure Activity Log is the subscription level logging. All subscription events will be logged in your Azure Activity Logs. The ingested data includes Azure Resource Manager operations and service health events, policy actions, etc. So whenever we create a VM, we update a VM, we delete a database, all these events are post requests that are done using Azure Resource Manager. So any interaction that you make to Azure Resource Manager, like a put or post request, that will be logged. If I simply see the resources, that's a GET request, that will not be logged. But if I make any changes, that will be logged in your activity log. Activity log provides insights into what operations were taken on the resource, who started it, when did that happen, the status, and other raw data that could help in auditing. Activity log is enabled by default. You don't have to make any configuration to receive these logs. These are enabled by default, and it offers a free retention period of 90 days. After 90 days, it will start rolling and the previous logs will be deleted. If needed, we can extend by sending the data to a storage account or to a log analytics workspace. We have the option to push the logs. Let's say your organization has a compliance requirement to keep all activity logs for 180 days. By default, we have 90 days. That's good. What if we need logs older than 90 days? Because our retention period is 180 days. In these kind of scenarios, you have the option to export activity logs to a storage account or to log analytics, and you can query it from there. So you can directly query activity logs from Azure portal. There are some filters available like subscriptions, time span, severity, resource group, resource, event initiated by, and you can also search for keywords and operations. So in this way, you will be able to query the data without the need to know any query language. But if it's an older data that is stored in log analytics, you still need to learn the query language to get the data from there. Now we need to understand where exactly Azure Activity Logs stand. So regardless of whether it's a compute resource or a non-compute resource, you'll have different types of logs available: application logs, diagnostics logs, and this is where activity logs are. So this is below your guest operating system and the host VM. You'll not be able to capture anything that is happening within your guest operating system. For example, there is an event happened within your Windows machine. That is not available in your activity logs. So activity logs are just about the Azure infrastructure. So if you make any action on the Azure infrastructure, you will be able to capture that. If it's anything related to the host VM, guest operating system, diagnostics, application, that will never come in your Azure activity logs. And this is where we position activity logs if you look at the resource stack. So let's go to Azure portal and see how we can see the metrics and how we can see the activity log. Log analytics, we do have a different module there. So at that point, I'll tell you how to enable logging for services and how to analyze the logs. All right, so we are in Azure portal. I'll just go to any virtual machine just to show you where you can find the metrics. So I can go to monitoring here. You'll be able to see the platform metrics here itself. So I can click on see all metrics, and that will take me to the metrics explorer. Here I can choose any metric that I want. For example, let's look for a percentage CPU. You'll be able to see that here. Let's say you want to add one more metric and compare with that. Let's say memory. You can plot both of them here and you'll be able to compare the difference between that. So that's how you can get the metrics without any configuration right out of the box. Now for activity log, any blade that you go, you will see activity log. For example, if I click here, my activity log will be scoped to this particular resource. The last 6 hours, this is the only event that happened here. But if I go to the subscription, I'll have a complete view of what are the activities happening in my subscription. So here at the subscription level, I'm able to see different activities, who initiated those activities. I can increase the time frame here. And let's say the last 24 hours, these are the different actions that happened in your subscription. You can add filters. For example, you can scope to a particular resource group or resource. In addition to that, you have the option to go for operation. If you know what operation you want to look at, for example, create or update VM. So if there was any write operation done on the virtual machine, you'll be able to see that here. Now in the event severity, you'll be able to choose the severity of the event. Also, you have option to go for event category. So event categories are very important. You'll be able to see different categories like administrative. Administrative includes all actions that are taken by administrators, like service principals, users, accounts, everything. Every administrative action will be coming under this category. Security is for Microsoft Defender for Cloud, any security alerts. Service health is health of the service alert. So when we discuss about Azure monitoring alerts, whenever alert is triggered, that will be added to the activity log. So you can check whether the alert was triggered or not. Recommendation usually comes from Microsoft Azure Advisor. Policy is when a policy action takes place, like deny, audit, deploy if not exist, etc. Auto scale comes into the picture whenever there is an auto scale activity happens. Resource health is the health of resources in your subscription. Let's say I have this VM and I want to know the health of that VM. Let's say it was shut down or restarted by someone. That will affect the resource health. Service health is overall Azure service health, like the VM service is available or not. So these event categories are very important because this will help you to narrow down your search. Let's say I go for administrative and I can pick all the actions that are done by my user account. So that will be under event initiated by, and I can type in the email address. And you can see it here. Now it's showing all the actions that I did in the last 24 hours. So that's how your activity logs work. If you want to export the activity logs, you have the option to download as a CSV for your analysis. But as I mentioned, this is only for 90 days. If you want to extend this, you can click on export activity logs and you will be able to add a diagnostic setting here to send this all categories or whichever you want to a log analytics workspace. So whatever activity logs added here will be automatically pushed to your log analytics workspace and it will follow the retention of your workspace. So that's how we work with metrics and activity log in Azure portal. Now let's see how we can work with Azure Monitor Alerts. Enable log analytics. So log analytics is a service that we use in Azure to store data that we collect from different resources in Azure as well as in on-premises. So it can be used as a data store for storing your logs. Now, what does Azure Log Analytics provide to us? First of all, data collection. So the data generated from resources in cloud and on-premises can be collected to Azure Log Analytics Workspace. It offers reporting and visualization. With the help of KQL, you'll be able to create rich reports and visualization. Workspace. So in order to ingest the data, we need to create a workspace in Azure. So you can have more than one or one workspace and in different regions as per your requirements. So mostly what we do is in landing zone architecture, we will have a centralized log analytics workspace. That's where we will keep everything. But in case your project needs a dedicated workspace and you just need to have a consolidation at that project level, you can create another workspace. That's totally fine. When it comes to the pricing of log analytics, there are two meters. There is cost for data ingestion calculated in gigabytes, and there is cost for data retention based on the number of days you want to keep the logs. So as I mentioned earlier, in the case of activity logs, the default retention is 90 days. Let's say you want to keep the activity logs for 180 days. First, you need to set up a diagnostic setting to send your logs to Log Analytics Workspace. After that, you need to ensure that the data retention period of the workspace should be at least 180 days. Then only you will be able to keep the data for 180 days. So Log Analytics offers 30 days of cost-free data retention. If you need more than that, like say 180 days, then you have to increase it and then there will be a cost for that. So as I mentioned, in order to store the data, we need to have a workspace. So we need to create this workspace in Azure portal for data collection. So workspace is a resource that we create in Azure to collect, analyze, aggregate, and visualize the data from onboarded resources. It could be resources from Azure, GCP, AWS, on-premises. Regardless of the location of the resource, we can onboard to log analytics with the help of agents or services like Azure Arc. Data isolation. You can create workspaces in different regions to meet compliance and data residency requirements. Let's say you have two regions, a DR location and a production region. You need to have all the production data in your production region itself. So you can have a workspace dedicated for the production region, and you can have another workspace in DR region to store the data there. So data that we collect from resources is stored in log analytics. We are clear about that. In addition to that, the data that is collected by Application Insights and Sentinel is also stored inside your log analytics workspace. So if you're using Sentinel, you'll see that there is a charge for Sentinel. In addition to that, there will be a charge for log analytics, because whatever data that Sentinel is handling is stored in a log analytics workspace. So let's go to Azure Portal and create a new log analytics workspace. I'm in Azure Portal and I'll just search for log analytics workspaces, and I'll create a new log analytics workspace. So I'll create a new resource group here, RGLAW, or let me call it RG monitoring. And I'll call this LAW monitoring. This will be in East-US. That's all you require to create a log analytics workspace. By default, it will be in the pricing tier of pay-as-you-go. That means I'll be paying for every GB of data that I'm ingesting. If I have ingestion of more than 100 gigs per day, I could go for a commitment here where I can reduce the per gigabyte pricing. So our workspace is created. Now we need to know how we can onboard the resources to the workspace. We will see that in the next lesson. Querying log analytics workspace. So we have different environments here, local environment as in the on-premise environment. Then we have other clouds like AWS, GCP. So all this data can be ingested to Azure with the help of Log Analytics Agent. Even though the XM is not updated, it's all talking about the Log Analytics Agent. But at the time of recording this course, Log Analytics Agent, or also known as Microsoft Monitoring Agent, MMA, is getting deprecated. So the new way of onboarding is using AMA, also known as Azure Monitoring Agent. Earlier, what we used to do was, if the machine is not in the cloud, as in Azure, in on-premises, we will be installing the Log Analytics Agent, and we will push the key for Log Analytics there so that it can speak to our workspace. But now the process is completely changed, but the exam is not updated for that. So the new process is using a service called Azure Arc. Azure Arc is the service that you can use to manage machines that are deployed outside Azure. So once we onboard the machine to Arc, what you can do is you can easily push the extension, just like you deal with an Azure VM. So remember, the new way of doing it is using AMA. If it is on-premises, it is using Azure Arc and AMA. But the slide is talking about the older agent, which is Log Analytics Agent. So keep this in mind. This is just for your information. Nevertheless, you need to push some agent to collect the data if it is not in Azure. It could be Log Analytics Agent, as you can see here, or it could be AMA, Azure Monitoring Agent. Once the machines are onboarded to Log Analytics, you can use Azure Portal to run queries against the onboarded machines or the data that we collect to visualize or do some analysis. In Log Analytics, what happens is, based on the type of data, there will be different tables created. For Windows Event Logs, it will be event. Syslog will be ingested to syslog table. Heartbeat is a table that is used to make sure that the agent that is running on the machine, be it AMA or MMA, that machine needs to report back to Log Analytics, letting the Log Analytics workspace know that I am alive. That's why it's called Heartbeat. Then we have perf table for performance metrics. You can create custom logs and give custom names to your table. You can also ingest alert information to the alert table. So all this can be queried using the Kusto query language. So to query something in performance table, I'll use perf, then I'll put my parameters, and I'll be able to get the data. Let's go to Azure Portal. I'll show you both methods, how to onboard using MMA and AMA, just for your information, so that you're aware of both the methods from an exam standpoint, also from an implementation standpoint. So I'll be creating a Windows machine, Linux machine, and app service, and let's see how we can collect data from these sources. So all these resources can be created with the help of a script. If you clone the GitHub repository called monitoring prep infra PowerShell script, you can execute that script and it will create a Windows machine, Linux machine, and a web app for you. So we are in Azure Portal. The script will create a resource group called RGSecOps, which will contain 2 virtual machines and a web app. This is a web app, and we have 2 virtual machines here. Now, first we will take the method which is going to get deprecated, installation of MMA. MMA is the older way of doing things. Wherever you go in Azure Portal, you will see banners talking about it is getting deprecated in August 2024, and Microsoft recommends that you use AMA. However, exam is not updated about the AMA steps. So in future, you will see that the exam will be talking about AMA instead of MMA. Anyways, we will see how we can do this for both the agents. For that, I'll go to my Log Analytics workspace. I'll go to sources and virtual machine right here. And I can see both of my machines are shown here. All I need to do is just click on connect. And remember, not all operating systems are supported by MMA. That challenge is also there. So we are using Ubuntu 22.04, which might not be supported by MMA at this moment. Anyways, let's see if these machines are getting connected. They're trying to connect right now. We will soon get a response. While these machines are getting connected, you can go to Legacy Agents Management. Here you will be able to input the logs that you want to collect. For example, if I need the performance counters, we got the failed message. We'll check that in a while. Let's say you want to collect all these extra metrics that from your machine, you'll be able to do that. Also for Linux performance counters, syslog, islog, you get some filtering here. So let's see why our machine was not able to onboard. So for that, what I'll do is I'll go to virtual machines. I'll check the Linux machine. Go to extensions. That's where the agent is going to be installed. So let's go to extensions. Our Windows machine got connected. That's a good thing. Here it says OMS agent for Linux. So if I click on this, it says install failed, unsupported operating system. So MMA doesn't support 22.04. This could be one reason where you want to migrate to AMA. And you can see that the Log Analytics agents, OMS or MMA, will reach end of support by August 2024. Azure Monitoring Agent is a recommended replacement. So once we do this, we will be able to collect logs. Our Windows machine is connected to the Log Analytics workspace. You can see that the MMA or Microsoft Monitoring Agent is provisioned for the Windows machine. Now what we need to do is we have to go back to our Log Analytics workspace and see if the machine is showing up here. So you can see that one Windows machine is connected using the legacy agent. 0 Windows machines are connected using Azure Monitoring Agent because we didn't configure that one. So if I go to the logs, I'll be able to see the heartbeat. So I can just run this and you'll be able to see the heartbeat coming from our Windows machine. Yes, this is our Windows machine. The category is direct agent. Keep this in mind once we install AMA. This is what we are going to use to understand from which agent we are getting the heartbeat. So this is how it is going to be. We are getting heartbeat. Soon we will start receiving the performance metrics and all that. Now we will see how we can use AMA. So to use AMA, what we are using is something called data collection rules. So I can define what data I want to collect. I just have to link my resources to that data collection rule and the agent will be automatically installed. So by the way, MMA and AMA can coexist. That means you'll get heartbeat from both agents at the same time. But remember, the data will be sent twice to the Log Analytics workspace. That means double billing. Anyways, I'll go to monitoring here. In monitor, there will be data collection rules right here. So let me call this one as AMA DCR. I'll put it in the monitoring resource group. Platform type, I'll select all because I want to collect logs from Windows as well as Linux. So data collection endpoint is something that we use with custom logs. For Windows log, syslog, this is not required. So going to resources, I'll be able to add the resources that I need. So what I'll do is I'll expand the SecOps. I'll be able to see my virtual machines, both Linux and Windows. I'll click on apply. Now collect and deliver. This is where you'll be adding the data sources like performance, syslog, etc. So I'll first add Windows event logs. Here I can configure what level of data I need from application security. So let me get all the critical in once. And after that, what I need to do is I can go to the destination and choose my Log Analytics workspace. Add data source. Now I'll do the same thing for performance. So I'll collect the basic performance counters like CPU, memory, disk, network, system, and process. The destination, I need to use logs, and I will point it to my Log Analytics workspace. That is added. Now I will add the syslog for Linux machines. Linux syslog. So I can choose the logging level, whether I want to go for debug, info, notice, warning. By default, everything is set to debug. Destination, I'll make sure that it goes to my Log Analytics workspace and data source. Review and create. And during this process, the AMA will be installed on all my machines. So you can see that it created a system assigned managed identity for installing the agent, successfully initiated extension installation. So it takes care of everything. I don't have to, go to workspace or anything. Now, what I need to do is I can go back to my virtual machines, go to my Windows machine here, and go to extensions. Here you'll see Azure Monitoring Windows Agent, which is the AMA that we installed right now. Now what I need to do is, the Linux will also support because 22.04 was not supported by MMA, but here you can see that it's getting installed as of now. So this will be updated. Now we will go back to Log Analytics workspace and we will take a look at the agents right here. So as of now, it is not reflecting here. AMA is not showing up here, only the legacy is showing up. Linux is also not coming up. So let's wait for some time. As soon as the first heartbeat comes to Log Analytics, we will see that one machine is connected using AMA and for Linux as well. After a minute or so, we can see that one Windows computer is connected, one Linux computer is connected. So I can click on See the Win Logs. We should be able to see the heartbeat from our Linux machine. There you go. So here the category is Azure Monitor Agent. So let me slightly change this. So I want the distinct computer and the category. So if I run this, you'll see that this Windows array is having two heartbeats. One is from the direct agent, which is MMA, and this is AME. And this one is only having AME. Now we are getting the data. Also, we started getting syslog. So if I run syslog, we should be able to see something. At least the table is created here. Yeah, we can see messages coming in from our syslog using our AME agent. Perfect. That's how we work with virtual machines. I would strongly recommend if you're going for a new setup, use AME. Don't go for MMA. Now for other resources like app services, what you need to do is, let's go to web apps. Since this is a PaaS solution, we don't need to install any agents on this. In fact, we will not be able to install agents because the compute, VM, everything will be managed by Microsoft. But still, we need the logs, right? In those kind of scenarios, what we do is we will go to the diagnostic settings. So this will be there for almost all resources wherever logging is supported. So I can create a new diagnostic setting here. I can choose the category. Let's say I want everything. And all metrics. I'll say AppDiag is a name for this diagnostic setting. I'll send it to my log analytics workspace. So this includes HTTP logs as well. That means if I simply go to the website, send a GET request, that should be logged. So what I'll do is I'll go to the overview. I'll click on this. So we are seeing the default landing page for our web app. Now what we will do is we'll go to Log Analytics Workspace. Logs again. So here, let's expand this table. Now we can see there is a new table called App Service HTTP Logs. In addition to that, we have event table, performance table. So all that data is coming in. So sometimes you will have dedicated tables, for example, App Service HTTP Logs. Sometimes some diagnostic settings, for example, SQL auditing, there was no dedicated table. It went to Azure Diagnostics. So you can always expand this and see the available tables, and based on that, you have to construct your queries. So let's run this one, App Service HTTP Logs, and we will be able to see all the HTTP requests that came in. And you can see the HTTP status code, the result, the query. So you will get everything. So I hope you got the idea. So based on whatever logs that we configure, there will be respective tables. If you're not able to find something, that will be under Azure Diagnostics. You can further filter that using your resource ID or some other factor. So that's how you onboard machines to Log Analytics to send the logs to the storage or to the workspace. So AMA and MMA. For exam, as of now, you just need to study MMA. But in future, it's going to be AMA. That's the reason why I'm proactively letting you know that. Perfect. Now we will move on to Azure Monitor Alerts. Enable Azure Monitor Alerts. So with the help of Azure Monitor Alerts, we can get notified on events that are happening in your subscription. So it offers something called a unified authoring experience. We can create alerts for activity logs, service health events, log analytics, metrics, etc. In all these scenarios, the authoring experience is same. You will get to see that in the next slide how the workflow goes. Classify based on severity and response. Azure Alerts support severities 0 to 4, so we can easily prioritize the alerts. Secondly, we can categorize by user response, new, acknowledged, or closed. Integrate with something called action groups. So you can define your notification and automation preferences with the help of action groups. You could send email, text message, make a call, trigger an automation account, function app, logic app, webhook. So you have a lot of options when it comes to Azure Alerts. So all these preferences on how to get notified, what automation should be invoked, is controlled using action groups. So when it comes to the creation of alerts, there are 4 stages or 4 steps that you need to be aware of. The first one is the scope. Where exactly you want to scope the alert, or what are the resources that fall under the scope of alert. So we have seen scope in other places like RBAC, policy, etc. So the same concept applies here as well. So whatever resources that you want to include as part of the alert, you can add it to the scope. In case this is an activity log alert or log query alert, you will be able to change the scope accordingly. We will see that during the demonstration. Next is the condition. So this helps you to define the signal and the criteria for alert. Here we are using %CPU as the signal, and the criteria is if the CPU utilization is more than 80%. That is the criteria here. In other words, if the CPU utilization goes above 80%, the alert will be triggered. Next is action. So in action, we define the action group, which action groups should be involved when the alert is triggered. As I mentioned earlier, action groups include the notification and automation preferences that you have for the alert. We will see action groups in one of the upcoming slides, and even during the demonstration, we'll be creating a new action group. And the last step that we have is the rule details. So we have to define the severity, the alert rule, the description, and all that, so that when you get an email, for instance, you should be able to see the name. And based on the severity, you should be able to prioritize the alert. So this is how we work with Azure Monitor alerts. In action groups, as I mentioned, you'll be able to define notification preferences and automation preferences. Under notification, you have the option to email Azure Resource Manager roles like owner, contributor, reader, monitoring contributor, or monitoring reader. If you choose this option, all the owners or all the contributors or whatever role that you're selecting, all the users will be notified by email. Another option is to configure email, SMS, push, or voice. So you can directly type in an email address. Let's say you have a group email address that you want to put there. You can put in the email address and it will send out emails to everyone. Under actions, we have automation runbook, Azure Function, Event Hub, ITSM, Logic App, Secure Webhook, and Webhook. So all these actions or automation preferences can be done from Azure Action Group. Let's say you have a service desk, you can integrate that with notification, and ITSM connectors will be used to send the alert directly to your service desk, and your administrators can review that. So this is how it looks in Portal. You'll be able to select the notification type and the action type while you create the action group. Enough with the theory, let's just go to Azure Portal and see how we can create an alert for a virtual machine or for any resource. So we are in Azure Portal right now. We could create alerts for log queries, activity logs, metrics, etc. So let's start with log analytics. I'll go to logs here. Let's say I want to take a look at the app service HTTP logs and where the time generated is greater than last 25 minutes. I'll take a count of that. Let's see how many requests we got. 51. So I can create a new alert rule from here. So the scope will be already defined, which is my log analytics workspace. The condition is I just have to take the count and I can specify the threshold value. The value that we got is 51. Let's say if I get 100 requests in 25 minutes, I want to send an alert. So that's how you author alerts when it comes to log analytics workspace. Now, if you are in activity log and let's say you want to search for create or update virtual machine. Not here. I'll remove this filter because we created a virtual machine in another resource group. Anyways, let's say create website because we created a web app. I can simply click on this action and you will have an option to create a new alert rule. So whenever this action happens, you can receive an alert. Similarly, if someone is deleting a production database, you will get an alert. So this is how you set up alerts from activity logs. But what I really want to demonstrate is setting up alerts on VMs because these are critical production servers and you need alert when the CPU goes above a certain threshold. So let's do this. Let's go to virtual machines. Take a Linux machine here. And what I will do is I'll create alert. I can directly go to the alerts blade and I can create it from, or I can do it from here as well. So I'll say create a custom alert rule. So if I do so, my resource will be automatically selected. Let's say I want to include the Windows machine as well. So what I can do is I can simply check this, click on apply, and the Windows machine is included in the scope. Next, the condition. So here I'll get access to all the signals that are there for this particular resource. If I'm selecting a storage account, the signals will be different because the metrics are different for different resources. So I'll take percentage CPU. I'll apply it. I have two options. I can go for static or dynamic. Dynamic means that the system learns your usage over time, and if there is a deviation in the pattern, it can send you alerts. Technically, this is good because it reduces a lot of noise. Sometimes the machine can go up to 80 and there is nothing wrong. It might be updating something or something is running, but that's quite normal. So if you want to reduce the noise, you can go for dynamic as well. But for the sake of the demonstration, I'll be using static. And the average CPU is greater than 80%. I'll check every 1 minute. And if I take the last 5 minutes, so let's say I check at 9:30, the system will be looking at usage from 9:25 to 9:30 and see the average percentage CPU. If it's greater than 80, the alert will be triggered. It will check again at 9:31 for the last 5 minutes and see what is the average. It will keep on doing it. So look back period is 5, that's fine. Next is action. This is where we set up the action group. As of now, I don't have any action group. So what I'll do is I'll click on create action group. So here I will give a VM notification and I'll say VM CPU is the display name. Next is the notification. This is where I'll define my notification preferences. Let's say I want email. So once I select email, SMS, push voice, I'll get a screen like this. I can define what exactly I need. For example, I need an email in this address. I can put SMS, app notification, voice call. This is the alert schema, as in there is a JSON payload. If you want to collect that, use it in your function app or something, you can enable that as well. So email, I'm good with that. I'll give it a name. Let's say email written. Next is actions. This is where you integrate with your automation runbook, Azure Function, Event Hub, ITSM, Logic App, Webhook. So if you have an automation running, whenever an event happens, then you can do it. Remember what we did with the key rotation in storage, right? So we can have a similar approach here. Whenever the alert is triggered, I can invoke a function and do something using a script. So for now, we are not touching anything on the actions. I'll click on review and create the action group. So the action group is created. It's already selected. I can have multiple action group associated to the same rule. That's totally fine. In the details, I need to provide the alert rule name. So I'll say this is the CPU alert, Windows and Linux. I can set the severity. Let's say I want to keep it as critical. In advanced options, you have enable upon creation. That means the rule will be immediately enabled the moment you create it. You can uncheck this if you don't want to resolve the alerts automatically, because the system fires the alert and it will resolve it automatically. If you uncheck this, someone needs to go there and close it manually. So whichever works for you, you can do that. I'll click on review and create. So while the rule is getting created, I'll explain what I'm going to do. I will use a stress program inside the Linux machine, shoot its CPU usage above 80, and let's see if I'm getting an alert on email. So this is our Linux machine that I'm going to connect. Let me open the terminal. Let me SSH. Yes. And let me copy the password. So we are good. I'll just update the machine. And I'll install the stress program. I'll just run it as sudo. Okay, perfect. What I'll do is I'll connect to the same machine again. Paste the password, hit enter. Here I'll open something called HTOP. So here I'll be able to see the CPU utilization once we start the stress program. So what I'll do is I'll go to sudo, just type stress. So you'll get the man page for stress here. So I want to get CPU and I want to use timeout as well for a certain period of time. Okay, so this is going to be stress for CPUs. Timeout is 1000 seconds. I'll hit enter. Now let's go to HTOP. You can see that the stress is running here and causing the CPU to go 100%. So we will keep it running. In some time, we will get the alert because we need at least 5 minutes of time to get the average utilization to be increased. Less than 5 minutes, the average should be about 80%, but for worst case scenario, we should get in less than 5 minutes. So let's wait for the alert to pop up. Meanwhile, we can go to Azure portal and monitor our machine. Go to monitoring, CPU average. You can see that there is a spike in the CPU utilization now. It was at 16, now it's going up, and we should see an increase. So let's wait for the CPU utilization to increase above 80, and we should get an alert by that time. So CPU is going up, now it reached 30%, the average. But in the last 5 minutes, our average is still like 6%. We have to wait for the average to increase above 80%. Now the CPU utilization is almost 100%, which is a good sign. Let's just wait for the average to increase, and I'll be getting an alert very soon. So looking at the average from 935 to 941, it crossed 83%. And I got an email for that. So this is how it looks. Azure Monitor rule was triggered for Linux RAVM at 1841 UTC. Over the last 5 minutes, the value when the alert was triggered was 8004. The operator is greater than, threshold is 80. This is a static threshold. So you get all this information in an email. So whenever we analyze this, we have to make sure that we are looking at the last 5 minutes. And if the average value is higher, that will be used for triggering the alerts. You can also check if the alert is triggered by going to the activity logs. So I can go to this virtual machines activity log so that we don't have to go through the entire logs. Also, I can stop the stress. So the VM should go down back to 3% or 1%. Good. Now here, once the alert is triggered, I'll be able to see that here. And let's see if I filter for event category as alert. It takes some time to show up here, but you can always use this method to verify if the alert was triggered. While we wait for the alert to show up here, we can go to alerts here in Azure portal, and we can see that CPU alert is fired. I can click on this. Then I can change the user response. I'll say acknowledged. Team is working on this. Now this will be updated so that someone else opens this, they will be able to see the user response. So after that, let's say you want to close this, you will be able to close it from here. Close it. Someone ran stress on the VM. Save it. This will close the alert. So that's how you can track the alerts in your environment. In fact, you can use this to set up your alerts, track your alerts, and you can also see the alert rules from here. Whatever alerts that you created, it will come up here. Great. With that, we have completed all the portions that are required for AZ-104 exam. And I wish you all the best.